Hello everyone, I'm Max Wolf, and today we're going to have some fun playing around with IMDb data the intended way. Now, whenever you see a lot of IMDb analyses on the internet, usually they scrape the data off IMDb. Let's go to IMDb.com. Works. So on IMDb.com, it's the Internet Movie Database, which is a database of movies on the internet. Simple name, really. So you can go to movie, and what you get is you can get information on the creators, you can get information on the stars, but what's also useful is rating data. For example, The Dark Knight is known for being the movie with the highest rating, most amount of votes. Got 1.2 million. Got a very intrusive ad. I need to install an ad blocker. Got 9.0, which is really good for IMDb ratings with 2 million votes. Down, you get a little more metadata. You get director, writer, stars, and cast, and a bunch of other things. Now, one of the popular data visualizations is to do, for example, ratings, votes, and down to detail. And what they do is people write a data scraper that scrapes the data at bulk, just crawls through the entire every movie available and finds all the data. And Kid Coopler says in chat, awesome to see R on Twitch. Thanks. I do intend to do a lot more with R, and believe me, this is just going to be the start. Things are going to get a lot crazier with R. So back to here. The big thing about IMDb, I said a lot of people tend to scrape data, but the IMDb is very picky about the data that you're able to use. If you Google IMDb Datasets, this is the official page for the IMDb Datasets. A long time ago, it was very inconvenient. What you had to do was you had to FTP into their server in order to get a data set from IMDb, and it was a pain in the ass to clean. And even if you did clean it, all the data had missing information, which was kind of a pain in the ass. But FTP is kind of archaic in terms of data organization. So one of the new things is there's now direct download for IMDb datasets. As you said, you have a list of downloads. You download it. It's a TSV, which is a very standard data format. It's compressed gzip. So once you download, you have to uncompress it. I've done that ahead of time, and what you have is this. Waiting. Size of Finder. I'm not seeing that. We have 7 CSVs. These files are pretty big. The file size. We have a 1.28 gigabyte CSV of principles. We'll get to what each of these data sets have soon. I wouldn't call 1.28 gigs big data per se, but it's enough that you could not do this in Excel. Try and open a 1.28 gig file in Excel, it will yell at you profusely. Now, there's a warning. You can hold local copies. It's subject to terms and conditions. Please refer to non-commercial licensing. Let's look at this brief. See why working with IMDb data has been a pain in the butt this time. Blah blah blah. Number 2, the data must only be taken from the datasets. You may not use data mining, robots, screen scraping, or similar online or data gathering and extraction tools on our websites. If the information and data you want is not present in an S3 dataset, it means it's not available for non-commercial usage. And that IMDb is very particular about that. Kaggle recently hosted an IMDb dataset, and they got a DMCA takedown from IMDb to get rid of the data. The data source I used for a few other data visualizations of IMDb was OMDB, which is open-end data API. I can bring that up. So this is a neat tool to access IMDb data in a more programmatic way, but there used to be a download feature, so you could download the data, which had a little extra metadata, and they had to get rid of that because of a DMCA takedown. That's why I'm in general, I try to end more on following terms of use. And this is a big subject of debate. As SGK7 says, "Oh, you're that Viz guy." Indeed, I am that Viz guy, and believe me, just wait until we get started. I'm working as a data scientist at BuzzFeed for about a year coming up, and let's say I've learned some new tricks that's done some relatively crazy things. Back here, the data can only use for personal and non-commercial, so don't make money off of it. That's easy to do, and disclaimer of where you got the data. That's reasonable. But the big thing is, I want to play with data, but do not want to get DMCA takedown. It's generally unpleasant. So let's talk a little about IMDb Dataset. I talked about data here. Unfortunately, there's IMDb lists the schema that each of the CSVs follows. Let's start with ratings, since that's also a small data set. Down to ratings. Contains the IMDb rating for votes and information titles. It's a traditional data architecture. Fortunately, it follows like standard industry things on how to engineer data. We got the identifier, numeric ID, the average rating of all the individual ratings, and number of votes. So it's the same amount of data available here. It's not as detailed. Like, for example, if you click into the data, you get a breakdown of each of the votes. And I wish I had this. I wish that data was available, but alas, it's not. But what can you do? And you got a few other things. For example, I guess got basics. Got an identifier. Got title things. A little bit normalized, but the big thing is all these identifiers have a unique identifier for the title, and we'll need that to do some joining of data sets. But well, that's gonna be fun. Let's start out. Let's get down to it for now, and if you need to, we can go back to the schema. So I went ahead, and in order to make things move along a little faster, I decided to engineer things ahead of time in RStudio. RStudio is an IDE for R, and I strongly recommend using it as opposed to the IDEs that come with R in both Windows and Mac. There's a lot of new cool features, and a lot of new ways to organize things. But the big thing about RStudio is R notebooks, and I do a lot of data work in R notebooks. Kid Kupler asks, how much Viz did you R compare to something like D3 Python? I'll say BuzzFeed is a Python-oriented in both Python-oriented company, but I do still use R for data visualizations. I do use Python for other things such as deep learning, and I do use deep learning at BuzzFeed. And I do hope to write something about that in the future, but we'll get to that at some point. So here's an R notebook. It's in R Markdown and .rmd file. At the top of an R notebook is relevant metadata. This metadata helps format the R notebook. I just copy and paste the format from the previous notebooks. Got title, got author, date. All of this help for SEO. You want to get that. I start the notebook off with all this is plain text. Unlike a Jupyter notebook, you can see just anything. You don't have to do like set things to like a markdown cell or code cell. That can be very convenient. And the top of our file, you list of files you want to import. For this thing, I generally keep things very simple. Tidyverse is the R library, which contains a lot of tidy packages such as dplyr for data manipulation in R, ggplot2, which we will get to use a lot. It has what else is in tidyverse? Got tools for working with factors. Got tools for reading data. It has reader, which we'll be using very shortly. and a few other things which I do make use of. But another few cool things for R is ggplot2 is ggplot, which gives the ability to plot text that can intelligently be distinct from each other spatially. Got gghighlight, which is a very new package. It just got released, updated on Crayon today. That lets you. Actually haven't used it at all, but I've seen the demos and look very promising. Where you can use like highlight certain parts of a chart, certain categorical views, and it's, again, demos are pretty cool for that. GG ridges are what you need to do ridge plots, which I've been making around very recently. That you can like do like a curve for each line, and it looks pretty cool. And lastly, tidy text is a library for breaking down text, and you can do some cool visualization with that. In general, working with text in R is kind of pain and doing tokenization, but tidy text works pretty well with that. I've been very happy with the results. Like in a Jupyter Notebook, you can just run each cell, runs that. The big thing here, ggplot2 is now version 3.0.0. That just happened today. And there's one very important utility that's now available in 3.0.0, which I will be making use of. It should be pretty cool. System information. All right, so now we got that. Let's read into data. But we'll start with working with ratings data, since that's the smallest data set. But just because it's only 14.4 MB doesn't mean it has not a lot of data. It's still a lot of data. So how do you ingest a file? Because these files are so big, I put them on an external hard drive rather. And so I did a little helper function that the folder was located on the external hard drive. And what you do is read TSV, which is the reader library with tidyverse. It can read the TSV. What does it give the corresponding file given this path. The NAs, if you go back to the schema, it says a null is a \n. So for reader, you want to tell that that's an NA, but R, because R is very weird, you have to escape your backslashes. You don't have to do it in Python. And in progress, this is a little bit of a QA thing. When you do an R notebook, if you and what R reader normally does is it gives a progress bar on how much data it's read, which is normally nice, but in R notebooks it can pollute the notebook because it'll do a line for every percent it reads, and that can be a bunch of garbage. So I generally just get rid of that, even though loading it can be slow at some point. So let's get to it. Let's read the ratings file and see what that happens. Then in addition to reading this rate file, I'll demo it by printing the head. Head will, by default, would be the first 6 rows of a notebook of the data frame. That loaded pretty fast. Reader can infer the schema. It's a character. The average rating is a double, which is correct, and number of votes is an integer, which is correct. Yep. And looking at the data itself, we got the identifier, we got an average rating, and the number of votes. Can do a little bit of detail on that. Actually, you know what? Let's go straight into the visualization. Another cool thing about R is it also lets you explore the data, and you can interactive. I wouldn't recommend doing it because if you do click that, it'll try to load all 847 characters, and sometimes that can hang it. So that can be a pain in the ass. I've hit that by accident, and it kind of sucks. So let's go straight into ggplot. If you want to do a real exploratory, let's try to do a scatter plot of votes and ratings. See what happens there. Let's ggplot2. Data frame is df ratings. Aesthetics are x-axis, we'll have x-axis number of votes. I feel like we'll want to do a log scale on that. Y-axis will be the average rating. But we'll do scatter plot, so that is a G on point. Oh? Wait, why are you erroring? Next, let's... Actually, you know what? I don't need anything else. Let's just leave it at that and see what happens. But a big optimization with ggplot2 I like to do, but not others do, is to do ggsave directly to the file instead of running it and having the output. If you do ggsave, it'll anti-alias, and that'll look a lot better. Save. And it'll follow the image format, so let's... 1.png. It'll infer from the PNG to save as a PNG, which is good. Pass the plot itself. With all this at, by default, ggsave will do at 300 dpi. So it'll be 12,000 by 800, which is good for a Retina display. 4:3 is a good ratio for charts in general. You can do 16.9 if you want to be fancy. What? Oh. It's camel cased, of course. It's plotting all of those points, and since I realized I'm plotting that many points, I realized I made a mistake. The mistake, it'll become very apparent once it's done. When it's done, I think it may have plotted a few too many points. And my computer, but the good thing about R, I guess, as opposed to something like Excel, is that you actually can plot that many points in a reasonable amount of time. If you try and do that in Excel, it will probably crash the file and maybe even corrupt it because it failed to load. Let's open that. And so you got a little bit of distribution. That's actually a little more interesting than I thought it would be. But you got number of votes. You got the average rating. And this is without any customization. You can see the plotting is only 2 lines of code. That's the power of R and ggplot2, and why I like working with ggplot, even when I do a lot of data science in R and Python. Even if I do like transformation of data in Python, I sometimes just export a CSV and then push into R. That makes my life a lot. But I do there is an optimization. The optimization is to bin it. And a way to do that is to do a stat summary 2D, which is a good way for doing like 3D histogram. So I think I can actually just straight from it. Oh, it needs a Z, huh? Wait, why does it need? It should be able to infer it automatically. Hold on. Oh. Try geom2. By default, it should do a count. No geom bin 2 data. Heat map of 2 2D bin counts. What we want. It rendered a lot faster since it only has to render like boxes instead of having to render 847,000 points. And there we go. That looked too bad. Doesn't look too bad. You can see that the majority of submissions don't get many votes. You could optimize by doing thresholding, but let's name science. Let's pretty this up a little bit. So a few axis optimizations. Let's optimize both the X and Y axis. I'm blanking. How do you optimize the axis? To tidyverse documentation. Actually pretty good for visually. Axis. Oh, scale. Wait, so here are the scaling functions which you use to prettify an axis. What I want to do for the votes is to scale log 10, and with that, scaling that as opposed to scaling the raw value itself makes things a little bit cleaner. And for handling the ratings, we want to do that, scale that from 1 to 10, which each interval. We can do that by scaling explicit breaks. And where is our... Whoa, not 10. Another thing I like to do is, by default, ggplot2 will import the scales library, and with that, you can label axes with either dollars or commas or percents. If you have tens of thousands of votes, the comma will be helpful. Here are continuous, and then breaks. And we want breaks for each number. The shorthand for that, we just do 10. And it will do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, let's rerun it with that. Object. Oh, it didn't import it? Ah. Fine, I'll import it myself. There you go. Go here, and wow, that looks a lot cleaner. Got average rating from 10. You can see that there's like a flat here at around like 6 to 9. You see it's a little flatter there. That's part of the reason why this like IMDb's ratings. IMDb follows a phenomenon known as the 4-point scale, where ratings tend to go to like 6 to 9. That's not as helpful. It could be calibrated better. Rotten Tomatoes data is calibrated a little more uniformly from high spectrum. You do what you gotta do. You can the bins are too big. We can force the bins to be a certain width, I guess. This. Number of bins. The bin width, if you want to. That. The x-axis we'll leave alone. The y-axis we'll do in increments of 1, so it'll be 8.1, 8.2, and so on and so forth. Or I'll just break the visualization entirely, which sometimes happens because I guess Binwidth doesn't accept multiple parameters. So it can't do x and y separately. That doesn't make sense. Oh, here we go. Can't use NA. Fine. Be like that. And I did not like 10, I guess. Because this log scaled, I feeling that's messing everything up. This is another part of data science that no one talks about, is just messing around with parameters and seeing what happens. All right, I have no idea what happened there. Well, you can see, I guess, on the y-axis that is indeed scaled by about like 1, but I have literally no idea what's going down. Remove that for now. Back to the base state. Oh, that looks cleaner. Got the count. And so let's, I guess now is a good time to talk about the feature that was added to newest version ggplot, which is kind of important. That feature is the Veritas scale. Fill. Veritas. It's continuous. Let's run that now. Now we have the Veritas scale. The Veritas scale is added in the latest version of ggplot. And the big thing about it is very colorblind friendly. Normally, in order to do the ggplot2, you have to import the Veritas package, which so it saves an import. Nothing wrong with that, but cool. And hopefully this leads to more adoption of Veritas. If you do an ordered factor in ggplot2, it'll use this Veritas scale by default. So, and if you do like matplotlib, and a few other Python visualization packages, Veritas is already the default, and that's been working out pretty well. Visualization world. 0 to 10s. Another feature I like to do. There's also multiple Veritas packages. Veritas palettes, rather. Option Inferno is one I like to use for my data visualizations. It's more, you can see it's a lot darker, and the areas around here stand out a lot more. You can see that there is like sort of 3D clustering with everything here just not being relevant. Like between 5 and 9. At 7. And that's the power of ggplot2. Started out pretty well. I think now it's a good time to switch to a different data set before I get on that. Titles. Let's go to the basics here. How large is that basics file? Basics, it's 525 megs, so that should take... Oh, title basics, no, 4.33. I guess... Well, I'll say this. I'm happy I have 16 gigs of RAM on this computer. Otherwise, there could be a little bit of a problem getting this data into memory. Another thing about our notebooks is that it follows Markdown formatting. So if you wanted to like embed the chart into the notebook, you can use the Markdown syntax for embedding images. Preview what the notebook looks like now. So it follows the theme, uses Space Lab class theme, so it's a little more modern, so to speak. Well, got the image embedded. The image is embedded high res because it's using the high res image file that saves instead of embedding the or generating into the notebook itself. Well, see, it automatically does section headers. I guess you could do table of contents. I don't like table of contents because they seem unnecessary, but could do a TOC equals true. And there you go. Not bad. Although I guess to follow proper markdown, you want to do H1s instead of H2s. All right, so back to working with title basics. I have the functions. I just cell file name title is called title basics CSV. On that. And I feel now it'll take a while, and since I turned off progress, I don't know how long it will take. So this stream's a little bit of an experiment. I guess I did advertise on Twitter and Facebook. What's this? Sounds like it worked, but it didn't. Let's see. All right, okay, it did load. So, 11,000. So I guess okay. I'm just a little disappointed. I think that's their fault, not my fault. I got 3.6 mil rows, and that's just teetering on. That's okay. That's in general a lot of data, and hopefully that's getting the advantage of having a strong computer. And let's take a look at the data. Damn it. Let's do with me. There we go. Okay, we got the identifier. So that will be important if you want to link it to here. Link it to the ratings. Got primary title. Got the original title. I guess these are foreign movies. Adult. That's a Boolean 0-1. If you got schema. Got the runtime. Okay, so that is present in this data set. That will be very helpful. Got the genres. Genres are nested. If you want to unnest them, you're gonna have to use tidy text. That's it. We only have 9 columns. So I guess now would be a good time to illustrate how a join works. Remember the DF ratings we have with all the ratings? Well, let's augment that with the information here. Both go back to here. Both the ratings has the tconst, which has the identifier, and here, and as conveniently they have the same name, so the join's pretty easy. But in this case, we only want to do join if the rating's present. There are fewer ratings than there are titles. So in that case, a left join will be a little more efficient. But joins are very easy to do in dplyr. Left join. And because the variable's name is same, we don't have to specify that what joining variable is. That's it, I guess. Run the head after that. And if it has correct, it should include all these fields for the corresponding. Go. Got augmented with pretty nifty. So now we can do we can map get rating and number of votes to other variables such as minutes and genres, and with that we do quite a few interesting data projects. What am I thinking? Let's do runtime. Let's see if there's a correlation between runtime minutes and rating the movie gets. Do that. It's going to be pretty much the same as the code I already used, and there's no shame with copying and pasting the plotting code you've already used. We'll want to do the 2D bin. Data frame is the same. X-axis. Let's change that to elapsed minutes. I do not want to log scale that. I think they'll think of the issue, but let's leave it at that for now. Run that and see what happens. Oh, we have two Y scales. Rude. The old file. What? Why is there a movie with 50,000, 5,000 runtime minutes? Welcome to data cleaning, the other fun part of data science. Alright, I'm curious. Curious what's going on there. Inspect the data quickly by sorting it by runtime minutes. And you got, what are weird? A documentary that's 1440. That's like 5 hours. How's that documentary? That got random things, but I think the general thing is movies have a certain length, so I should probably restrain that a little bit if possible. You can do, thanks to the magic of dplyr, you can do filtering at line. So let's say less than 4 hours. That filter. And looking at data with a lot of shorts, so it might be helpful to filter it minimum as well. Say at least. Let's run that, see what happens. And oh, we have distinct clusters, huh? Interesting. Although distinct clusters are like below. Oh, that I guess this gives good opportunity to fix this axis a little bit, but. Looking at this, I think we can filter that a little further and just go 3 hours. Let's go to 180. And what I want to do is specify the axes an hour. To do that, do a little bit of a visualization trick I like to do. So we'll specify the breaks. But the breaks will be every 60 minutes. that you do sequence of 0 to 180 by 60. So it'll return a vector of 0, 60, 120, 180, which is what you want. But the labels are where things get interesting. The labels, you can do them in hours, so we got 3 hours, just do 0 to 3. And there we go. Although it's not runtime ints, we'll probably want to change the axis name. You can see there's a cluster here. Because basically, I'm guessing these correspond to different genres of movies. These, like, guess these are probably more traditional. These are probably like shorts that are lower than 1 hour. I guess that's something that'd be worth looking into. Now that we have that, I think this would be a good opportunity to demonstrate how to prettify a chart to make it, I guess, something that you could theoretically post on Data is Beautiful. Although although the quality of Data is Beautiful has been intermittent. First thing we want to do is access late. First thing is to apply a theme. Minimal is what I do for my data viz. Font I like to use is Source Sans Pro, which is a free font from Google Fonts. Just install it and run that immediately. And guess that changed it a little bit. You see a different font. Here, not too bad. Although it didn't change that much, but it will change once we add axes labels. Just one thing to do is comma because now for the fun part we can label the chart. But there are multiple functions you can do in ggplot2. You can do like X title, Y title, but the easiest part is labs. The relationship between movie runtime average movie rating a relatively recent feature in ggplot2 is to add subtitles, so you should always do that if applicable. You'll use subtitle to identify data constraints, such as the source of the data. Since they're about citations, retrieved by fourth. X-axis. Remember, I changed it to hours, so let's say hours. Y-axis. Another thing about adding a caption, which I use for personal, i.e. don't steal. That's rude. Happens to me, happens. Both. M dash is best dash. Let's run that. Although you might want to play with the fonts a little bit since it's spilled out a little bit. Another optimization here is because it takes up so much room on the side, you may want to move it above the chart. Theme. position equals top. Trick, position equals top. And actually don't say count because it's boring, so fill empty string. That again. And that problem's a little harder to fix. It's very greedy about data it takes. What I do is I usually copy code and like removes the margins. Just very aggressive about that. Meantime, the easier fix is just increase the width. You can actually decrease the base size here. Base is 11, so let's do 9. And that works. That works not too bad. Got things here. If it were like posted on a blog or posted on Art Data is Beautiful, I'd probably identify what's going on here, why they're two separates. And I'm feeling I think we can do it now. It might be a little tricky. What we want to do, I strongly relate to genre, I have a feeling, but I think we have time. We can do that. What we want to do is unnest it. That take DF ratings. And the big thing about unnesting is that it will take a lot of. It'll be the resulting will be huge. Sometimes I think if it's only 2 or 1 or 2, it might only double or less than double it. So I guess that's not terrible compared to how big this data frame is. But the issues with working with like medium-sized data that could push against RAM is you have to be very smart about it. You can't YOLO data science, even if it's very seductive to do so. Got DF ratings, and what we want to do to manage memory usage is to only unnest take data we need. So to do that, we'll select the variables using here. Minutes and the genres itself. Now it's time to unnest. Unnest tokens from tidy text, and what that does is what we want to do is get each genres. Genres. I think the default tokenization should work fine. Anyways, but let's YOLO and see what happens. After it does that, let's do that. Object genre. Oh, I think I transposed it. Oh no, I didn't transpose it. I did a plus instead of a pipe. That's. Am I? Oh. Damn it, you're right. Pointing out the video and sound isn't synced. And that's because video sound is distinct. How do I resync my? Test 1, 2, 3. Okay. It's my computer's fault, not the stream's fault. Test 1, 2, 3. Test. Test 1, 2, 3. Okay, that looks like it fixed it. That's weird. Wonder if it out of caches. Yes, that's the only thing about streaming you learn just by doing it. And thanks, Kid Coupler says it works is better, so I'll take his word for it. Now let's try and run this. And oh, it appears to have worked. What it does is generate. If you go back here, so what it does is it'll generate a row for documentary and a row for short. It'll generate a row from animation, and a row for short, animation, row for animation, row for comedy, row for romance. And that looks like it did that. The benefit of that is now you can facet on genre. Let's do exactly that. It's the same exact plot, but oops, plot, change the things, and then we're gonna do the cool thing is to add facet. I believe there are quite a lot of genres. So let's make the chart a little bigger and let's see what happens there. What it's going to do is generate a chart for each genre, and hopefully that'll identify why there are two distinct clusters on that. Whoa. There we go. And so what we have here is comedy. Oh wait, I didn't normalize this, did I? I have to normalize it before I can. I mean, it has to be a way of normalizing ggplot2 instead of normalizing it at the data level, I think. Huh. See if there's. I guess there could be an option in. If there's a way to do, or maybe faster wrap to. Scale option, scale the. Wouldn't be it. Alright, fine, I'll do this the hard way and I'll just scale log 10, see what happens there. I think, or it's or so you have to give it a. So that it's scaled at log 10 and oh, well, this is an interesting little thing. Not entirely sure if it's helpful, but see that there are indeed clusters in all genres. It's not like there's not like a short where it's all shorts. Some genres have some do have movies that are less than 1 hour. Some have movies between the 1 hour 2 hour mark. So that filter didn't help that much, but it resulted in a pretty cool data viz. So I have no objections to that. If I did post this on Data is Beautiful, I'd get a votes, and people taught me to kill myself at some point. All right, so let's go back. Something else I wanted to look at. So start year versus end year. Maybe that could explain why things are. Let's map start year to. So you can do a scatter. Start year versus. Other than that, we'll need to use this. Actually, let's do start year versus. I think there was a submission Data is Beautiful about this a while ago. In which case, I'm not intentionally doing that. It's an interesting subject. No, that's not this versus rating that movie. I have a data frame here, so all I need to do for the time being is to copy and paste one of my old ones. It does have it. Sure. Start year. Start year is. It's all camel case. That's why it's average rating. Texas. Year of its release. Don't. That I do y-axis as is. And this is interesting to see why IMDb is a little bit biased that 1950s movies, the olds aren't good. Let's get again. Cluster. As late in 2000s gets a little better. That kind of matches with the generation of demographics of IMDb's users, which is interesting. Let me. And okay, that was not helpful at all. Does follow that. And another thing to do. I think what would be interesting is like look at the distribution by the decades. Rich plots. Actually, let's not talk about decades yet. We can. That instead of doing bin 2D, we want to do a bridge line. And actually I haven't done a bridge line in a very long time, so I have no idea. I have actually no idea what's going to happen. Except I guess that's not necessary, but it might be interesting to see what happens. Object height not found. Let me look at documentation because I know it's changed recently. Height measure. See? GM density bridges, okay. Here too. It's identical, draws closed polygons rather than bridge lines. I think this should be fine. Oh, no, object Y not found, but I did want to do. Rather greater than or equal to. Object Y not found, what does that mean? Okay. Right. That's... What's going on here? Now you can see the other side of data science, the part where things fail and I'm not entirely sure what I'm doing wrong. I have my MX, my... I'm missing a... I may have to... Happens. Let's do this hard way. Google it. Density that is what we want. That overflow. That is not helpful. Also, definitely something very stupid I'm doing. Another possibility is that there's an undefined thing and it's just get me really unhelpful. It'll always have a rating, but it may not always have a start year. Let's try doing start year as discrete. Oh, what is going on here? All right, I'm gonna do some hardware. I need to make sure this does. Oh wait, what's? Hold on. I don't think that'd work. Just run this to make sure this code is actually. All right, working. This is kind of what a rich plot should look like. I do think these are transposed though. Maybe that's why it's yelling at me, because average rating. Still yelling at me like suck. This is the correct route. Gaslighting myself again. For years, I'll int have average. Object Y not found. I'm gonna figure this out. I'm not ending the stream until I figure this out. Why is the Y? What about stat density? Guess that change anything? That wouldn't do the rich plot. I would just do all the variables, but I guess that's a way to debug this. GM density instead of GM density ridges. All right, so something's wrong there. Guess it's not an issue with the violin plots. It's an issue with scaling. The GM density is normally more agreeable with this. Because I think I know what's going on here. Because it's a count. Trying to do like a histogram, but shouldn't be giving me that error at least. That doesn't make sense. I equals. It's not good. Wait, I just did that. Ugh. Oh, so it only passes one variable. How do you do that passing two variables? It should. You have to scale widescreen. Why not found? It's very specific. Bruh. Maybe it is a stat identity thing. Doesn't help. Okay. I want to waste. Comment it out. I'll figure it out offline. I do plan to do all this into a blog post in order to keep the stream moving along. But I will figure that out if it's the last thing I do. Instead of doing original. But you can still do, I guess, interesting things by faceting. So what did I have before I get sidetracked here? Just another approach gets to be truncate to decades and then do a facet on it, which works. I have no objections to that. ggplot2 actually has a help function called cut or I haven't actually used it, but I saw in documentation. I do want to cut by decades, so it'd be cut width, length. That should work. Set out. I want to just cut each year into 10 year intervals. Left by default. I want to apply this. Up a little bit. Do full pipes. What? Huh? There weren't any unclosed parentheses. Oh, there wasn't unclosed parentheses. Great. But that shouldn't have caused a crash. I deserve that. But you know what the good thing is about a crash? Wow, it kicked me out of my project? Right? And it looks like it did save, at least. That's a good thing, but because it crashed, everything broke. So I need to reload everything. But the good thing about an R notebook is that it's just run through all the steps before it, and you're good to go. So in this case, steps before include loading giant files, which took a little bit to load, but what can you do? It's much better than like than doing ad hoc, which when I first was loading R, I just mastered it and then it broke. Mastered the scripts, just messing things around. Sometimes it broke. in a way that just rerunning the script didn't fix. That was a major pain in the butt. And that's one reason against like command line things, because when things break, it's a big time sink just to time to the join. All right, that was okay. Now let's get back to what I was doing. I was trying to see how to use a cut. This time not. So instead of doing it in the consoles, in case it crashes again due to my stupidity. And got a comment: is R better for data science than Python? It depends strongly on what you're doing. I actually learned R in college, and learned like the strong statistical techniques to use R. And it turns out it was actually a royal pain in the ass, and I almost hated the language entirely. And that was one of the reasons I actually learned data science in Python for a bit. So that was a pain in the ass too. And then after that, eventually the tidyverse came out. You got dplyr, you got deeper integration from ggplot2, and using dplyr and ggplot2, in my personal opinion, is better than R and better than Python's pandas and other plotting libraries there like matplotlib and seaborn. But that's just my opinion. Don't ever say on Hacker News or you will get destroyed. Speaking from experience. But in my work at BuzzFeed, I do use both Python and R depending on what I'm doing. Filter on that. Do I know Stephen Lim? I do not. Next start date. Let's hope it doesn't. Wait, let's go back. Let me go back to documentation on this. Object want to pull it. In dplyr, pulled returns as a list. And it truncate. Nice, although ideally should. So it would be better if it started at 1950. So let's add. One of the docs were here. Center 0. Either boundary 0 or center 0. That. Okay, so I hope that's. So I think that's technically. That's that. Yeah, that's actually correct. And comment. What am I looking at here? This is data visualization on IMDb data. Let me just scroll back. What I'm doing is creating data visualizations. Like one of the ones I did is trying to correlate the number of votes on a movie in IMDb versus the average rating. Other stuff doing just. I'm trying to pass it by genre to see if there's like different trends by genre. For example, this is all exploratory. I'm not trying to build a statistical model, but it's a little more. I guess I don't know if I call it EDA. Just I guess it's extra E, in my opinion. I like doing visualization. I like doing more than just like histograms. So there's a place for histograms or bar charts. Guess if I'm doing that, I have to let me implement this properly. All part year. So whether to do cut each year into decades, then what I'm going to want to recode that. And because the good thing about tidyverse is that tidyverse includes forecats, which is a good library for encoding factor variables. And by default, this cut interval returns a factor. But I can factor and then levels. Hopefully that worked. That did not work. Great. Because I want to do labels instead of levels. How much memory is this using? Or was using? All right, let's. It's that hard to cut into decades. What is going on here? Oh. I guess I can say in our studio you can organize projects as projects. The benefit of that is you can have separate workspace for each project, which helps organize things. And another benefit of having a project is you can have a separate Git repository, which you can do to make changes, and then once you're done, you can just push the repo to GitHub. It's a pretty nice workflow, in my opinion. Now I have to go reload everything again. Another way to reload things without gets automated. Another thing I like to do just to fix after breaks is to select and do run all chunks above, but in this case I don't want to do that because one of the data viz, the first one took a little too long and I don't want to rerun that cell. Oh wait, I removed that. Never mind, I can. Start R. Environment's empty, that's good. So this is actually neat. What it does is, cool feature of RStudio is it runs through all the chunks and it gives you a little progress bar. RStudio is it runs through all the chunks of all it's doing, which is pretty. My computer is... Test. Okay, good. I have a feeling all this processing is slowing down the audio processing, which is kind of annoying. I'm gonna have to look and see if there's a way around that. Or worst case, forgo some of my audio altogether. Alright, so everything's done. Got all the data up. Like, got all the joins. It's unnested. So let's try and do this again. Hopefully it won't kill me. I'm beginning to think that this visualization is not going to happen. Implementing this wrong. Why is this happening? Hope it's not out of memory. I might pass on this too. This isn't less entertaining for streaming. All right. Let's load one last data set before I. Oh, episodes. Another data set that IMDb has are the episodes of TV shows. Which are somewhat interesting, but I think there might be caveats there. Hold on. Comment in chat. Oh, okay. Did the audio just cut out? That's embarrassing. Well, while I was ranting that I'm not a fan of D3 because D3 is kind of exclusionary too. D3 is kind of very exclusionary to beginners, and I dislike the attitude in the industry about onboarding people with D3 because it's such a high learning curve, and saying you can't be good at data visualization unless you use D3 is, in my opinion, a little bit of gatekeeping. A good workaround for using D3 is to use Plotly, which is, I believe, based on D3, and there's an interface to Plotly for both R and Python, and there's actually a cool tool with ggplot in particular that you can use it to automatically generate Plotly from ggplot somewhat natively with pretty good results. I've done that for a few of my blog posts. But there are a few trade-offs with interactive visualizations in terms of dependencies, which, in my opinion, aren't worth the hassle, especially when you can do a lot with simple 2D. So, what was I doing? Right, I was trying to load a new data set. So what I want to do is load episodes. I'm sorry about all the audio issues. I wasn't expecting this. I'm feeling this is, I don't know. Wait, damn it. I clicked too fast. It overwrote the rating, so I'm gonna have to rerun that if I need that. And with the mic audio issues, lost half my audience, which was kind of expected, to be honest. To read the head. Why are those NAs? That's weird. NAs. All right. So let me go back to the schema. What the episodes thing is, it contains episodes for TV shows. IMDb, instead of is more than movies, it can be TV shows as well, which might explain some of the issues I was seeing earlier about like badly clumped heat maps with very low runtimes. So what this here has got a new unidentified episode, identifier of the parent, season number, and the episode number. And what might be interesting is to aggregate like how long TV shows go on. That we can do a little bit of dplyr manipulation. Show ag. Let's aggregate by, let's say, average amount of episodes per season. This is probably very preliminary. There are probably a few data fidelity issues with here, like some shows, depending on how IMDb classifies it, there would be a lot of issues publishing this. But let's see. That's just I'm thinking going ahead myself. Putting on now, see what happens. Well, yeah. dplyr, you want to aggregate. I saw you got the parent, which corresponds to the show, and the season number. You don't know how many episodes are, so we can aggregate, group by these, and aggregate, and guess it would be count the sync number. and a cool dply function to automatically count tally. Oh, of course. I remember when I was doing data projects before, and I kept hitting this R session aborted. I feel the solution was to completely reinstall R, gently. So I have a feeling I might have to cut this stream to a close. It's been going on for hour 41 minutes. Oh, that's more than I thought it would go. That's not too bad. But I apologize for the technical issues. I will write a blog post on a few of the things here, and maybe on maybe spruce up the visualizations a bit. It'll include code. It'll be based off the notebook, but I hope you learned something new working with IMDb data. It's more robust than I thought it would be. I'm sure there's some cool things you can do by deep diving to a little bit further, but yeah. Keep an eye for the blog post. If you haven't followed me on Twitter or Facebook, this will be available as a VOD on Twitch. I will copy to YouTube, and yeah, I hope you had a good time. And I do plan to keep a regular stream. So if you haven't followed me on Twitch, and yeah, that's the gist. I apologize for the mic issues. I'll see if I can sort them out. If hopefully, worst cases I can identify and prevent it from happening, but let's see. I'm not fond of random mic issues. As a data person, random issues are kind of annoying. I like non-random issues. But yeah, I'm Max Wolf, and I'm signing off, and I hope to do a stream once a week. Yep.